In this video, we are going to discuss about poles and zero of network function. A network function h of s can be expressed as ratio of two polynomial a of s to b of s like this. That is, h of s is equal to a0 s raised to n plus a1 s raised to n minus 1 plus etc. an, all divided by denominator polynomial, that is b0 s raised to m plus b1 s raised to m minus 1 plus etc. plus bm. Let it be equation number 1. Here a0, a1, a2 etc. an and b0, b1 etc. bm are coefficients of numerator polynomial a of s and denominator polynomial b of s respectively. These coefficients are real and positive for passive network. When we are factorizing numerator and denominator polynomial of this equation, it can be written as a0 into s minus z1 into s minus z2 into s minus z3 etc. s minus zn, all divided by b0 s minus p1 into s minus p2 into s minus p3 etc. s minus pm, where z1, z2, z3 etc. zn are roots of numerator polynomial a of s, which is equal to 0, and p1, p2 etc. pm are roots of denominator polynomial b of s is equal to 0, and the ratio a0 by b0 is a constant k known as scaling factor or scale factor. Here z1, z2, z3 etc. zn of transfer function or network function is called zero of network function. Here, when we are substituting s is equal to z1, h of s becomes 0. Similarly, when we are substituting s is equal to z2, h of s becomes 0. So, in general, when s becomes zn, h of s becomes 0. That is, the network function becomes 0 when s becomes equal to any one of the 0, that is from z1 to zn. So, those value of s at which network function becomes 0 is called zeros of the network function. Zeros are denoted by a small circle in complex frequency diagram, and that frequency diagram is usually termed as S-plane. Similar way, P1, P2, P3 etc. Pm is called poles of the network function. When S become Pm, network function become infinite. When we are substituting S is equal to P1, this denominator becomes 0. That means h of s become infinite. So that means network function become infinite when s is equal to any one of the pole. A network function is completely defined by its poles and zero. In a network, if it contains only one zero or only one pole, then that pole is said to be symbol pole. That zero is termed as symbol zero. If poles and zero are repetitive, the network function is said to have multiple poles or zeros. Just like in the case of zero, poles are denoted in complex frequency domain, that is S-plane by a cross X. Let's see one example to see how to plot pole zero plot in complex frequency diagram. For that, let's consider an example. Draw pole zero plot of the network function z of s is equal to s plus 4 divided by s. Here z of s is a of s by b of s. A of s is numerator polynomial, that is s plus 4, and denominator polynomial is es. Equating numerator polynomial is equal to 0, we can obtain 0, that is s plus 4 is equal to 0. That is s is obtained as minus 4. A of s is equal to 0, that is s is equal to minus 4 is 0. There is only one 0 at s is equal to minus 4. Therefore, this 0 is a simple 0. And equating denominator polynomial is equal to 0, we can obtain poles of this network function. We can obtain s is equal to 0 as pole. So there is only one pole at s is equal to 0. Therefore, it is a simple pole. So we have symbol 0 at s is equal to minus 4 and we have symbol pole at s is equal to 0. Now we can draw the pole 0 plot in S-plane. S-plane is a diagram or graph in which sigma represents real axis and j omega represents imaginary axis. As we know, poles are denoted by cross like this, and zeros are denoted by symbol circle, small circle. So at s is equal to minus 4, here we can have 1 0 that is represented by small circle like this, and at s is equal to 0 we can have one pole that is denoted by a cross. So this is the pole 0 representation corresponding to this network function. So next three problem left to you. Please draw the pole 0 plot corresponding to these three network functions.